All right, we've spent a little time simplifying radicals, adding and subtracting radicals, and now, although we have seen that you can multiply radicals, now we're going to do it a little bit more deliberately in a few more problems. All right, let's remember that the square root of 2 times the square root of 2, you can multiply those. You get the square root of 4, and in that case you got a perfect square, so it's equal to 2. It's going to be very useful if you remember a square root times itself, you get the radicand as a rational number. Now if you were multiplying the square root of 2 times the square root of 3, you simply get the square root of 6. If it can be simplified, you do. But please remember, a square root times itself, you get the number as a rational number outside the radical. All right, let's take a look at our first example. We have the square root of 6 minus the square root of 5, quantity squared, which means times itself. I'm sorry that my radical signs are kind of messy. I'm going to do this by FOIL because although these are not polynomials, they behave just like them. So this behaves like multiplying two binomials. The product of the first, we have the square root of 6 times the square root of 6, and we get 6. Now, if you want to, you can multiply them to get the square root of 36, but that is 6. The outer product, I have the square root of 6 times the negative square root of 5. Positive times negative is negative. The square root of 30. Can you simplify the square root of 30? I do not believe there is a perfect square factor of 30, so the answer is no. Inner. The inner product, I have the negative square root of 5 times the square root of 6. Negative times positive is negative, square root of 30. Together, these become negative 2 square roots of 30 because I can add them. They are like radicals. Finally, for last, I have the negative square root of 5 times the negative square root of 5. Negative times negative is positive. The square root of 5 times the square root of 5 is, yes, I know it's the square root of 25. Hopefully, you'll become comfortable with just jumping straight to that step. So the product of these is 6 minus 2 square roots of 30 plus 5, or 11 minus 2 square roots of 30. Okay, let's look at another example. I have the square root of 10, parentheses, the square root of 10 plus x times the square root of 30. This time the kind of multiplication I'm going to do is not FOIL, it's distributive property. So I'm going to multiply the square root of 10 times the square root of 10, and that's going to be the square root of 100, or maybe you remember, that's 10. And then I have the square root of 10 times the square root of 30, and there's an x, so I'll simplify that one again in just a minute. So it's plus x square root of 300. I multiplied the 10 times the 30 because they were both radicands. All right, now to simplify. 100 is a perfect square. Its square root is 10 plus x times. Now how am I going to factor the square root of 300? I just noticed that the square root of 100 is a perfect square, and that's the square root of 3. So that's how I have factored the square root of 300. This is 10 plus, the square root of 100 is 10. I'm going to put it in front of the x, 10x, square root of 3. And that's actually all I can do with that. So I used FOIL on the first one, and I'm using the distributive property on this second one. Let's see what we'll do next. All right, I have the square root of 6 plus my radical times the square root of 5 plus the square root of 7. This is distributive property. So I have the square root of 6 times the square root of 5, which is the square root of 30, plus the square root of 6 times the square root of 7 is the square root of 42. Now, I think about the factors, perfect squares that would go into 30. Does 4 go into 30? No. Does 9 go into 30? No. Does 16? No. There's no perfect square factor. The same is true about 42. So although those sort of look like I should be able to simplify, I can't. And that's it. All right, let's do another one that is squaring a sum or difference. I have the square root of 3 minus the square root of 7, quantity squared. If you want to, you write it out twice. Square root of 3 minus square root of 7 times square root of 3 minus square root of 7. Most people end up doing that. The product of the first, square root of 3 times the square root of 3 is 3. That's the first. The outer product is negative square root of 21. The inner product is also the negative square root of 21. The product of the last, negative times negative is positive. The square root of 7 times the square root of 7 is the square root of 49, which is 7. Now, this is going to happen anytime you square an expression like this. This is going to pop out of the radical, and this is going to pop out of the radical, and the outers and inners will be the same. Now, if you combine like terms, the first and the last, 3 plus 7 is 10. These are like radicals. There are minus 2 square roots of 21. Okay, let's do another one. What would we do here? This one, we're going to use the distributive property. And I'm really glad that this problem is here because students sometimes make a mistake that I want to caution you about. When you're multiplying here, 5 is a rational number, meaning it is not under a radical. These are irrational numbers. This is rational. All right. When I multiply those, I cannot multiply the 5 times the 2 because this is the radicand. All I can do is say 5 times the square root of 2. When it comes to multiplying 5 times negative 3, those are both rational, so yes, I can do that. So let me just say a couple of words. If you have the square root of 5 times the square root of 2, you can multiply them for 10. But if you have rational 5 times the square root of 2, you can't do anything with that. It is left as a product. And of course, if you have 5, whoops, I've not figured out why that happens. 5 times 2, where they're both rational, you get 10. So notice, when they're both irrational, meaning they're radicals, you can multiply the radicands. If one's outside and one's inside, that's all that can happen. And if they're both rational, you can multiply them. Okay, so there's nothing more I can do with that number 5. All right, number 6 looks nice and inviting. We have 2 times the square root of 7 plus 9 times the square root of 3 times the square root of 7 plus 4 times the square root of 3. The first, and maybe it's a good idea to go ahead and write it out this time. I have 2 times the square root of 7 times the square root of 7. 2 times, what's the square root of 7 times the square root of 7? It's 7. You know that it's the square root of 49, but that is 7. So the product of the first is 14. Outer. Give myself a little more room. The outer product, I have 2 times the square root of 7 times 4 times the square root of 3. The rational numbers, 4 times 2 gives me 8. The radical numbers, the irrational ones, I can multiply those for the square root of 21. And I can't simplify the square root of 21 because there's no perfect square factor, so I leave it. Inner product. I have 9 times the square root of 3 times the square root of 7. I'll leave the 9 on the outside. Square root of 3 times square root of 7 is square root of 21. It's very common that the outers and inners will be like radicals. I can add those together for 17 square roots of 21. The last, I have this, I have 9 times the square root of 3 times 4 times the square root of 3. Multiply 9 times 4 for 36. The square root of 3 times the square root of 3, we know it's the square root of 9, but that's 3. So now multiply that for 108. The full product is, my goodness, up here somewhere. So sorry. I laid my hand on something on the screen. The full product is 14 plus 17 square roots of 21 plus 108. Because these are both rational numbers, I can add them. That's going to be 122 plus 17 times the square root of 21. You certainly don't have to write all this out, but just for clarity, I thought it was a good idea. All right, let's look at one more. I have the square root of 7 plus x, quantity squared, so I'll just write it down twice. All right, the product of the first. Square root of 7 times square root of 7 is 7. The outer product is x times the square root of 7. The inner product is another x times the square root of 7. X times x is x squared. I can combine the outers and inners. I have 7 plus 2x square root of 7 plus x squared. And that's a kind of an unusual expression, but it is this quantity squared. All right, you get to work on yours now. Good luck with your homework.